Hey guys, welcome to the AWS VPC tutorial, and in this particular session we'll be learning VPC comprehensively. So I'm Kodishwaran and I'll be teaching you the concepts in VPC, what is VPC, the different components in VPC, that's the most important part. So internet gateways, NAT gateways, NACLs, and other components which are available in VPC, everything will be covered in this particular tutorial. So this would be a pretty long and extensive tutorial, so make sure you watch the whole thing so that you get the entire service. Okay, and before moving on with this session, please make sure to subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. And also, if you have any queries, please leave a comment down below and we would address all of your questions. So now, without any further ado, let's get started. So guys, let's start off by understanding what is Amazon VPC. So Amazon Virtual Private Cloud enables you to launch AWS resources into a virtual network that you defined. So in the AWS cloud, you basically have to define a virtual network, which is basically an isolated network in your own AWS account. So now this virtual network closely resembles a traditional network that you would operate in your own data center with the benefits of using the scalable infrastructure of AWS. So basically, when you're using AWS, there are millions of people, millions of companies using AWS. Right? So in this case, what happens is you would have to isolate your resources from the others' resources, or you would have to isolate your resources in your own account from other resources in your own account. So for that case, you can have a VPC, a virtual private cloud, which creates an isolated network inside the AWS cloud. So even though it basically resembles a traditional network setup, you can still use AWS's architecture in order to scale up or scale down your infrastructure. And also, one of the main common use for Amazon VPC is it's the networking layer of Amazon EC2. So if you do not know what EC2 is, go ahead to our previous tutorial on Amazon EC2 and learn about that, and then come back to this tutorial so that you could get a better understanding of what EC2 is, because when we are looking into the demos, in that case, we'll be using EC2 to demonstrate certain aspects of VPC. So in that case, you would have to know what is EC2 and how to create an EC2 instance. So for that, you can go ahead and look into it. Okay, so now this is what VPC is. Okay, so now let's just look at the key concepts in VPC before we move on. So first of all, VPC, Virtual Private Cloud, a virtual network dedicated to your AWS account. So again, it's dedicated to your AWS account, and also it will be dedicated to a particular region. So there are many regions in AWS which you can choose from. So under each region, there would be a default VPC available. And then you can create more VPCs. About that we'll see later in the session. So now, so it is basically dedicated to your AWS account. It is not shared with anybody else. And then a subnet. So under a VPC, you can have multiple subnets. So a subnet is basically a range of IP addresses in VPC. So let's say your virtual private cloud VPC allows around 64,000 IP addresses. So now you can create a subnet which allows around 4,000 IP addresses, and so that subnet allows 4,000 IP addresses, and you create another subnet which allows 10,000 IP addresses, but they cannot overlap because they are individual subnets. And the subnet 1, which has 4,000 IP addresses, the range of 4,000 IP addresses, will have a set of IP addresses which we can assign. So if you launch a instance, EC2 instance within subnet 1, it will have an IP address within that IP address range which has been provided. And then same thing if you go with subnet 2, which has 10,000 IP addresses, which has a different range of IP. In that case, if you launch an instance within that, it would have a different IP address, which would be within that particular range of IP addresses. Got it? Okay. So next is route table. So it's a set of rules called routes that are used to determine where network traffic is directed. So this we'll also learn later in the session. Internet gateway, a gateway that you attach to your VPC to enable communication between your resources in your VPC and the internet. So as I told you, the VPC makes sure that it isolates your resources in your VPC from the outside world or from any other VPCs in the AWS network itself. So how would the communication happen? How, let's say you are opening your instance and you want to download something from the internet. If the VPC doesn't allow that, in that case, you would not be able to download any applications. Okay, so for that, you can use internet gateway. So an internet gateway is attached to that VPC. So once it's attached to the VPC, any resource within the VPC will be able to access the internet. So that basically is an internet gateway. And then a VPC endpoint. So it enables you to privately connect to your VPC, support AWS services and VPC endpoint services powered by private link without requiring an internet gateway, NAT device, VPN connection, or AWS direct connection. So a VPC endpoint is another concept, another tool in VPC. So in this case, let's say you have another service, another AWS service, and you want to connect to your service within the VPC. But let's say in this case, if you want to connect within your own AWS account, in that case, it would be much better to connect privately rather than connecting publicly over the internet, because that would be unsafe, right? So if you want to connect privately, for that case, you can use a VPC endpoint. You can create a VPC endpoint for your resource, which can be used to connect to the resource. So let's say you want to access S3 from your EC2 instance. S3 is a storage service. So let's say you want to access the storage service from your EC2 instance. One way you can do is from the AWS CLI directly via the internet. So if the internet gateway is attached, and if you have given permission, if you have configured your AWS command line interface, you can access S3 from your EC2 instance. But if you have not done that, in that case, let's say you create a VPC endpoint for that S3 bucket. Okay, so now using the VPC endpoint without going through the internet, you can connect to the S3 bucket directly via your just the VPC endpoint. Nothing else is required. All right. Okay, and then there is CIDR blocks. So CIDR blocks are called classless inter-domain routing. So this is the Internet Protocol address allocation and route aggregation methodology. So when I was talking about subnets, I said there would be a range of IP addresses, right? So to provide that range of IP addresses, you would have to use a CIDR block. A CIDR block decides from what IP address to what IP address would be the range of that particular subnet. So it has its own methodologies, which is again a completely separate major topic. So we'll be learning about CIDR blocks as well. I'll be giving you the basics of all of these concepts. So that's what we'll be learning. All right. Okay. And then default and non-default VPCs. So if your account was created after 2013-12-04, so it comes with a default VPC. So if it was created before 2013, so in that case, you would have already created a default VPC by now. It's been so many years. But if you have created, most of you would be creating your account after 2013. So in that case, your account would already come with a default VPC and a default subnet. So once you create your own AWS account, AWS themselves create a default VPC and a default subnet within the default VPC for you. So that's what they do. So if you have a default VPC, you don't have to specify any subnet when you launch an instance. So in the previous AWS tutorial, AWS EC2 tutorial, you can see that when I'm launching an instance, I'm not going to specify any VPC or subnet. If you just launch it in the default VPC, it will launch it in a random subnet, whichever it chooses. You don't even have to provide your preference on which subnet you want to launch it to. So you can do that without even understanding what VPC is. You can get started with EC2, Elastic Compute Cloud, without even understanding what VPC is or what default VPC is. So later you can get a better understanding of what VPC is. So that's what we are doing right now. So again, if you've not watched the EC2 tutorial, please go watch it, do the demos over there, and then come over to this particular tutorial. All right. Okay. So you can also create your own VPC and configure it as you need. So this is known as a non-default VPC. Subnets that you create in your non-default VPC and additional subnets that you create in your default VPC are called non-default subnets. So basically any VPC which we are creating is called a non-default VPC. And in the non-default VPC, we'll be creating certain subnets. Okay, so those subnets are non-default subnets. That's the only difference between default and non-default. Default is created by AWS and it will be already available when you create an AWS account. Later, if you are going to create and configure your own VPC, that would be a non-default VPC. All right. Okay. So now VPCs and subnets. So I already gave you a brief about what a VPC is. So virtual private cloud is a virtual network dedicated to your AWS account. I already told this. So now it is logically isolated from other virtual networks in the AWS cloud. There are going to be a lot of virtual networks, right, in the AWS cloud. So maybe in just your account, you might have 4 to 5 VPCs. So let's consider all the customer base in AWS. So in one particular region, there can be, let's say, hundred thousands of VPCs. So now your VPC will be completely isolated from all the other VPC unless you have made a connection with another VPC. Okay, but until then, everything will be isolated. Your VPC, the resources within the VPC would be isolated from all the other virtual networks in the AWS cloud. So you can launch your AWS resources such as EC2 instances inside your VPC, and VPC will make sure your EC2 instance, that is your resource, is isolated from all the other instances and all the other resources and all the other VPCs. So when you create a VPC, you must specify a range of IPv4 addresses for the VPC in form of a classless inter-domain routing block, CIDR block. For example, 10.0.0.0/16. So this is the primary CIDR block for your VPC. And also a VPC spans all of the availability zones in the region. Okay. All right. Okay. So now let's come to the first point again. So here you can see that they're asking us to specify an IPv4 address range. So when you provide this IPv4 address range, that would be the complete IP address of this particular VPC. So the range of IP addresses. So the range would last from 10.0.0.1/16. So it would go to so it is 16, right? So 16 in the sense 10.0 would remain stagnant. It would be the same. Only the last 8 bits will change. So this total 10.0.0.0.0. So let me just make it clear. So these, right? So the total is 32 bits. And they've provided the subnet mask as 16. So when it's 16, that basically means the first 16 bits will remain unchanged. Okay. So now that basically again means only these bits, these 16 bits can be changed. All right. So in that case, so what happens is, so the range of this particular IP address would be 10.0.0.1. So, okay. And so that would be the starting IP. And the ending IP would be 10.0.255.255. So there are so many possibilities within that particular IP address range. Okay. So this is what you'll have to know. Okay. So yeah, so this is how you provide an IPv4 address. And so also when you create one, it will automatically show you how many IP addresses are possible within that particular IP address range. Okay, and then there is VPC, availability zone A, B, and C. Okay, so in a region, there are, let's say you've created a VPC in a region. So let's say I've created a VPC in the North Virginia region. And if the North Virginia region has 3 availability zones, the VPC will span across all the availability zones. If that particular region has 6 availability zones, the VPC would span across all the 6 availability zones. That is, if I launch an EC2 instance in availability zone A or availability zone C, it doesn't matter. I can still launch them within the same VPC, even though they are in different availability zones. So availability zone is a logical divide in an AWS region. Okay, so that's basically what availability zone is. There will be multiple data centers, so that let's say you can have your application running in multiple availability zones. If one availability zone is down or has some issues, you can basically redirect the incoming traffic to your application to the other application which is running in another availability zone. All right. Okay. So this is basically what VPC is. And then coming to the next point. So this particular following diagram shows a VPC that has been configured with subnets in multiple availability zones. So 1A, 2A, and 3A are instances in your VPC. So over here you can see 1A, 2A, and 3A are instances in the VPC. Okay, and one more thing you have to know is, so as I told you here, so let's consider this is the same VPC. So 10.0.0.0/16. All right. So we are creating 3 subnets within the VPC: subnet 1, subnet 2, and subnet 3. And over here you can see subnet 1's IP address range, that is the CIDR block, has been provided as 10.0.0.0/24. This is 10.0.1.0/24. Again, same thing, it's 10.0.2.0/24. So the thing is, the IP address range you're providing for your subnet cannot, so it will be within the IP address range of the VPC, but it cannot be the same as the IP address range of a VPC. So if your IP address range of the VPC has been provided as 16, so you cannot use the same subnet mask as 16. It should be more than that. It should be 20 or 24 or 30 or something like that. Okay. So in this case, 10.0.0.0/24. So this basically means that the first 24 bits will remain unchanged. Only the last 8 bits will be changed. Okay. Because total 32 bits, it's 24 bits. So the first 24 bits will remain unchanged. The last 8 bits can be changed. All right. Okay. So same thing goes here. One of the address, let's say 10.0.0.1, it would be 10.0.0. Let's say 10. So that can be an IP address. So here again, so the first 3, that is the first 24 bits will remain unchanged. So all of the IP addresses will start with 10.0.1. Yeah, so that will basically be the distinction between subnet 2 and subnet 1. So subnet 3 again, it will, all of the IP addresses within the subnet will start with 10.0.2 and the rest will follow. Okay, so this is basically subnets. And about route tables, we're not yet there. We'll talk about later in this particular session. And yeah, so these are basically the subnets, and over here you can see there are 3 instances launched, right? 1A, 2A and 3A. So now you can see the IP address of the 1A instance. Okay, so it's 10.0.0.5. So as I told you, it would be within this IP address range. So now let's see the IP address of 2A. So this is the private IP address, not the public. Public IP address would be totally different because it should be globally accessible, the public IP address, and globally unique. It cannot be a repeating IP address. So this is within the subnet, that's why it can repeat. All right. Then the private IP address of 2A is 10.0.1.5. You can see the first 24 bits are unchanged. Same thing coming to subnet 3, 10.0.2.5. So again, first 3, that is the first 24 bits are unchanged. All right. Okay. So these are subnets. Basically, it's a segregation or it's a range of IP addresses within the VPC which you have created. All right. That's it. Okay. Next is default VPC components. So default VPC components. So basically I would just wanted to share with you guys what are the components in the default VPC which AWS will create for us. So as I told you, once you create an AWS account, default VPC will already be available in your account when you start working with it. You can start with EC2, you can start launching instances directly because a VPC would be already available and you don't have to create any. So in the default VPC, what are the different components available? So the first one is obviously the VPC itself. So it will be provided by this particular address 172.31.0.0/16. So this particular IP address range, it allows 65,536 private IP addresses. All right. So these many IP addresses are possible in this particular IP address range. So now create a size/20 default subnet in each availability zone. So then they create, let's consider North Virginia itself, the North Virginia region. So there are 6 availability zones in the North Virginia region. All right. So in the North Virginia region, they are creating in each and every availability zone, they are creating a subnet which has the size as /20. That is the subnet masking as provided as /20. Okay. And when it's provided as /20, it allows 4096 addresses per subnet. So out of 65,000, so let's say there are 6 subnets, so it would be 4096 into 6. So there would be these many IP addresses available in those subnets, in those individual subnets. So there would be an individual subnet for every single availability zone. Third, they would be creating you an internet gateway so that if you create an instance in any of the subnets, that instance should be able to access the internet, or from the internet, you should be able to download something over the instance. Okay. And then add a route to the main route table that points all traffic to the internet gateway. So what this basically means is, in the route table, in the main route table which has been created, they are adding a route which is targeting all traffic. So what it basically means is all kinds of traffic from the instance can go through this particular route and reach the internet using the internet gateway. So it's routed to the internet gateway, so that particular resources, that is these instances which are launched within the VPC, get access to the internet via the internet gateway. So over here you can see, right, in the main route table, so this is the internet gateway connection. Okay, coming to the next one, create a default security group and associate it with your default VPC. Once the VPC, let's say you are creating one, you'll also have to create a security group eventually. But here they already have created a default security group and associate with your default VPC. So security group is created and attached with your default VPC automatically. And when you're launching an instance, you can still use the default security group. And then there is create a default network access control list, ACL, and associate it with your default VPC. So network access control list is more of rule. It's a rule set like a firewall where you can basically control the access, whether it's coming from a different IP address or whether it's coming from one particular range of IP addresses. Let's say you want to take off access to this particular VPC for a range of IP addresses. You can do that with network access control list. Or if you want to only allow access to a certain number of IP addresses, let's say it's an internal application, you only want to allow the IP of the company's network, the IP addresses of the company's network to be able to access your particular application. So in that case, you can use a network access control list even for that. And finally, associate the default DHCP options set for your AWS account with your default VPC. So the DHCP options are basically the domain name, the domain names, complete host name. So all of that details would be in the DHCP option settings, and that the domain name for the VPC, everything will be associated to your default VPC once it's done. So these are the default VPC components, guys. So the thing is, when we create a VPC, we can manually create all of this as we want. So if we want an internet gateway, we can create an internet gateway and attach to it. If we want to change the route to in the route table, we can do that. If you want to create another security group and attach it to your VPC, you can do that. If you want to create a NACL, you can create that. If you want to create a NAT gateway, you can create that. So we can do a lot of things with VPC. So that's what we'll be doing in the demo. And before that, let's just figure out and finish up all the concepts so that we would know what exactly we are doing in the demos. Okay, next comes the internet gateways. So the internet gateway is a pretty simple concept. An internet gateway is a horizontally scaled, redundant and highly available VPC component that allows communication between your VPC and the internet. So now the VPC, as I told you, it's an isolated network. So now the isolated network, what if it needs, let's say, had to communicate with the internet? So let's say a resource within the VPC wants to communicate with the internet, or some entity or some third-party application from the internet wants to integrate with an AWS resource within the VPC. So in that case, you would need an external entity, right, to allow this communication to happen. So that communication is basically internet gateway. So internet gateway lets this happen. So internet gateway makes sure that the resources within the VPC are able to access the internet and vice versa. So an internet gateway serves two purposes. To provide a target in your VPC route tables for internet routable traffic. So it will create a target for your resources. So when a resource is trying to access the internet, it can use that route, and that route would be the IP address of the internet gateway, which can be used to route and communicate with the internet. And the second one is to perform network address translation for instances that have been assigned public IPv4 addresses. So for the instances which has public addresses, public IP addresses, for those particular instances, internet gateway can do NAT, that is network address translation, in order to make sure it communicates with the internet. All right. Okay. Coming to the next one, which is NAT gateways. A NAT gateway, again, from the name itself, it's a network address translation gateway. Okay, so you can use a NAT gateway so that the instances in the private subnet can connect to services outside your VPC, but external services cannot initiate a connection with those instances. For example, in internet gateway, it is both ways. That is, the resource in the public subnet can access the internet, and a third-party tool or a user from the internet can access the AWS resource within the subnet. So that's basically an internet gateway. Now coming to a NAT gateway, let's say you want to configure your resource. So what if you just wanted the connection to be one way, that is, only the resources in your subnet, in your VPC, needs to access the internet, but the entities of a third-party entity from the internet should not be able to initiate a connection with those instances in the private subnet. So that's where NAT gateway comes in. So NAT gateway, from this diagram you can see, so this is the internet gateway, right? And this is the NAT gateway. which has the Elastic IP address. And okay, so let's say, so these two are subnets, okay, and these are instances. Okay, so you can see Elastic IP addresses are provided for these instances, and there is no Elastic IP address provided for these instances because these are private instances. Private instances only have the private IP address because they are not publicly accessible. Only if they are publicly accessible, they would have a public IP address. So Elastic IPs in this case are public IP addresses. Okay, so now so this is basically the NAT gateway, right? And now let's say this 10.0.1.5 instance, this particular EC2 instance wants to access the internet. So now it only has the private IP address. It cannot use the internet gateway because internet gateway only does network address translation for public IPv4 addresses. It does not do it for private IPv4 addresses. So that's where NAT comes in, NAT gateway comes in. So now this instance, while it's trying to access, it will be routed to the NAT gateway, and the NAT gateway would understand that, okay, this is a private instance, and it will basically translate the private instance's IP address in order to access the internet, and then it goes through the internet gateway and access the internet. So with the NAT gateway, the private instances can access the internet, but the third party entity can only access the public instances which has public IPv4 addresses. They cannot access the private instances which do not have public IP addresses, which only have the private addresses. Okay, so I think it's pretty clear here what is the distinguish between internet gateways and NAT gateways, right? Okay, so when you provision a NAT gateway, you're charged for each hour that your NAT gateway is available. So once you create it, so if you leave it like that, for each hour it will get charged, even though if you're not using it, because it's not a service you can stop or start. It's just an entity which is created and it's available in the subnet. So if you're not going to use it after some time, after practice, delete it because you will get charged, and each gigabyte of data that it processes. So when the private IP addresses are trying to access something from the internet, let's say if they are downloading 2 gigabytes of data into the instance, so you would also have to pay for that particular network packets which are coming in. So that's what they are saying here. And finally, the NAT gateway replaces the source IP address of the instances with the IP address of the NAT gateway. Okay, I think this particular sentence makes it pretty clear. For example, let's say this instance 10.0.1.5, the IP private IP address. So this instance wants to access the internet. So now, as I told you, it will be taken to the NAT gateway, and the NAT gateway will do network address translation, translates the private IP address of the instance, and it attaches the IP address of the NAT gateway itself, which will be able to access the internet via the internet gateway. Alright, so this is basically how internet gateways and NAT gateways work. So now moving on to the next topic, which is network interfaces and elastic IP addresses. So network interfaces is a separate thing, elastic IP addresses are a separate thing. So now let's see what is a network interface. So an elastic network interface is a logical networking component in a VPC that represents a virtual network card. So usually in a regular hardware system, so every particular network would have, or in every particular server would have a network interface, or a network card. So in this case, it's a virtual network card. So what does this network card have? So that's what they're listing here, the attributes of this particular network interface. So again, every EC2 instance would have a network interface attached to it. So there would be a primary private IP address. There would be one or more private IP addresses if we want. There would be one elastic IP address associated to it, a private address. So then there would be one public IP address, one public IPv4 address. So if we enable this, there is an option called auto assigned IP address, public IP. So that is enabled, it will automatically launch an instance and provide it a public IP address. If it is not given, then it will only have the first three, that is the private IP addresses. Then later, if you want, we can attach another elastic IP address. So that doesn't come with the network interface by default. And then one or more IPv6 addresses. Again, if enabled, we would get IPv6 addresses. Security group, most probably at the beginning, you would have one security group. Then if you attach multiple security groups, then obviously there would be more. And then a MAC address, and then the destination check flag, source or destination check flag, and finally the description of what that particular resource is. So these are the attributes which will be available in an elastic network interface in AWS, so in VPC. So this will be attached to EC2, and these are the IP addresses which will be available. These are the description. These are the different types of attributes which will be available. Okay, and then the next one is Elastic IP address. So an Elastic IP address is a static public IPv4 address designed for dynamic cloud computing. So you can associate an Elastic IP address with any instance or network interface in any VPC in your account. So with an Elastic IP address, you can mask the failure of an instance by rapidly remapping the address to another instance in your VPC. To put it very simply, let's say you have two instances, EC2 instances running. Both of the EC2 instances have the same application running inside of them. Okay, so now let's consider, so we have not attached any Elastic IP address to this. So now this particular instance will have a different public IPv4 address, and the second instance will have a different public IPv4 address. So if, let's say, the first instance is the primary instance and the second instance is the secondary one, so the primary instance will be running all the time. If the primary instance is down or there is any maintenance going on, then the secondary instance would be running in behalf of it. So now if there is a failure in the first instance, the IP address of the second instance is completely different, so there would be a minor downtime for that particular IP address change to be made. Okay, but what if you can use an Elastic IP address which is static? It won't change even when your instance restarts. Let's say you terminate an instance, Elastic IP address will still be available. You can attach it to another instance. It will still be the same IP address. Okay, so what I'm meaning here is, if you attach that Elastic IP address to that particular subnet or that particular instances, so if this particular instance fails, there would be another instance running, but the IP address of that instance also will be the same, because you have attached an Elastic IP addresses, and that would basically rapidly remap the address to another instance in your VPC without any delay. So that's why we have to use an Elastic IP address. But the thing is, if you create an Elastic IP address and attach it to an instance, there is no cost to it. When it is attached to an instance, there is no cost to it. But if you do not attach it to any instance, there would be a cost. So you would get billed for it. So if you create an Elastic IP address, either use it or delete it. Again, this is if you are practicing it. Later you can use it however you want, but obviously if you're not using an Elastic IP address, delete it if it's not integral to any of your services. Okay, all right. And the next topic is route tables. So a route table contains a set of rules called routes, and that are used to determine where the network traffic from your subnet or gateway is directed. So already we discussed about this, right, when we talked about internet gateway. So in route tables, there are various components. So the first one is main route table. When you create a route table, there would already be one. So the route table that actually automatically comes attached to your VPC when you create it would be the main route table. So if you see the default VPC, there would already be a route table available. You can create another one later if you want to, but that default route table which gets created when you create your VPC is your main route table. So it controls the routing for all the subnets that are explicitly associated with any other route table. So that is, it basically means if there is a subnet which is not associated with any other route table, it will control the entire routing for those subnets. Then there is a custom route table which you can create for your VPC. It's in your hand. Then destination, the range of IP addresses where you want traffic to go. For example, external corporate network with CIDR 172.16.0.0/12. So if you want the IP address range within this, so this would be our IP address range. So it's an external corporate network, and you want only the systems, that is the computers with these IP addresses to access your particular resources in your AWS VPC. Okay, so in that case, you can set it up like this by providing the destination with the appropriate CIDR block. And then the target, the gateway, network interface or connection. So whatever is the target. So for example, this would be the target, and this would be the IP address which you'll have to provide. Okay, in this case, the target is internet gateway, IP address is all traffic. Okay, and then comes route table association. So the association between a route table and a subnet, internet gateway or virtual private gateway. Again, so this is the route table. So it has been associated with the internet gateway. So that's basically is the subnet route table association. And then subnet route table, a route table that's associated with the subnet. So when you associate a route table, especially to a subnet, that basically means that is associated with the subnet. So that would be called a subnet route table. And there is something called a local route, a default route for communication within the VPC. Within the VPC, you can provide the IP address of the VPC and connect it to the VPC. That would be for all communication which is happening within the VPC. Okay. All right, guys. So now to understand even better what is a route, each route in a table specifies the destination and a target. So the destination is the range of IP addresses and the target is the target component in VPC. So in this case, the target component is internet gateway and you want to allow all traffic through the internet gateway. So that's why you are providing this particular destination. Okay, for example, to enable your subnet to access the internet through an internet gateway, add the following route to your subnet route table. So this is basically what they are telling us to do. You can also do this. So that's, again, I'll be showing that in the demo. The destination for the route is 0.0.0.0/0, so which represents all IPv4 addresses. The target is the internet gateway that's attached to your VPC. Okay, so basically the internet gateway is attached to your VPC and that would be the target, and the destination would be the IP address range, which is 0.0.0.0/0, which represents all public IPv4 addresses. So that basically means it provides access to all internet. Okay, so the next topic is VPC peering. So VPC peering is one of the main concepts in VPC. Again, it's a really easy concept to understand. So a VPC peering connection is basically a networking connection between two or multiple VPCs, mostly two, that enables you to route traffic between them privately. So if you do not want to use the internet, let's say you have two VPCs and there is an instance in VPC A and there is an instance in VPC B. So now the instance in VPC A has a private IP address. The instance in VPC B will also have a private IP address and a public IP address. Okay, so now let's say you want to basically make sure this instance communicate with this instance. You want to like establish connection, or you want to log in into this instance from this instance, or log in into this instance from this instance. So now if there is no VPC peering connection, in that case both of these instances should be public. Only then they can access each other, only then they can communicate with each other. But in this case, with the VPC peering connection, they can communicate with each other with just their private IP address without even having to go to the internet. So instances in either VPC can communicate with each other as if they are within the same network. So to establish that, you will have to do a VPC peering connection. It's pretty simple. You just choose a VPC as your requester and another VPC would be the acceptor. So VPC A would request VPC B to get into a peering connection, and then once VPC B accepts it, the peering connection is established, and then all the resources in VPC A can communicate with the resources in VPC B via a private connection between them. Okay, so the same thing, you can connect multiple VPCs. So over here to the right side, you can see VPC A has a peering connection with VPC B as well as peering connection with VPC C. So you can have multiple VPC connections as well. So in this case, you can also create a peering connection between VPC B and VPC C if you want to. There is also multi-region peering, that is a VPC in one particular region, let's say North Virginia, can connect or can create a peering connection with another VPC which is in, let's say, Ohio region. You can also create a peering connection between VPCs in two different AWS accounts. So a VPC, I have a VPC and I have an instance, and let's say there is a friend of mine who has a VPC in his AWS account, and there is a database, and I want to access that database from my AWS account, and I don't want to do it publicly. I want to do it privately within the AWS network itself. So in that case, you could create a peering connection with that particular account, and then you can use your instance to access that database resource within their VPC. So that can be done using VPC peering. So this is one of the most important concepts, and also a really easy concept to understand, and also a really easy concept to start working on. Okay, so these are the different components and these are the different topics in VPC, guys. So now let's just move on and let's get started with the demo. We'll be starting off by creating a VPC. I'll be showing you what are the different components once you create a VPC. Then I'll be showing you how to create a subnet, that is a private subnet and a public subnet. And I'll be showing you how to create an internet gateway and attach it to the VPC, how to create a NAT gateway and attach it to the VPC, and then also how to create a VPC peering connection. And yeah, so these are the things we'll be covering in this particular tutorial session, guys. So now let's move on to the demo. So guys, now we're going to start off with the demo. So first, open the console. I hope you already have created your AWS account and already have done the EC2 demos. So right now we're going to straight up start off with the demos in VPC. So the first thing you'll have to do is again open the so basically in EC2, I just wanted to show you guys. So as I told you, while you're creating the EC2, the second option is basically to select the VPC you want. And over here you can see there are security groups, Elastic IP addresses, network interfaces. So these are concepts which we learned in the theory part. So these also combined with the VPC module. Okay. So now I'm going to search for VPC. So isolated cloud resources. This is basically the VPC service. So once you open VPC, again, there will be a dashboard which will show how many VPCs are available, how many subnets are available, how many route tables are available, internet gateways. There are no NAT gateways, no peering connections. There are 3 network ACLs. There are 92 security groups. So no Elastic IP addresses. So every single thing is provided in this particular dashboard, and also it will show that whether Amazon EC2 is working properly or not, because VPC is the networking side of EC2. Okay, without the networking side of EC2, you cannot launch an EC2 instance because you need a network to launch an instance, right? So here you can see you can either launch an EC2 instance or you can open the VPC wizard. So let's create a VPC. So that's the first thing we're going to do in this particular demo. So launch VPC. So here you get an option to launch using the configurations which they already have. So this will basically create a VPC and a public subnet inside of it already for you. So it's a ready-made setup. So you can do that VPC with a single public subnet, VPC with a public and a private subnet with a NAT gateway can also be created without anything. You don't have to put any effort. You can just select this and it will create this exact same thing for you. And then VPC with public and private subnet and also hardware VPN access. So when do you need this? Let's say you are in an on-premises setup. So now if you want to access your on-premises servers as well, so to access that you need a certain connection, and obviously your on-premises setup, it's not VPC. VPC is only available in AWS. So in this case, you would need a VPN connection, a virtual private network connection, which creates a secure connection between the on-premises network and the AWS cloud, which allows you to basically transition and connect to your corporate data center so that you can basically communicate with the servers in the corporate data center from AWS and vice versa. And finally, VPC with a private subnet only. So this is just for communication between the corporate data center and the AWS resources. There is no public activity. There is no internet activity in this case. So you can use the VPC wizard. Okay, if not, you can open your VPCs and click on create VPC. And you can see I already have tried long back. Let's just see this. Yeah, so again, you can see this is not the default VPC because I created it. So this is the default VPC. You can see default VPC. Yes. This is again another VPC. And again, this is not the default VPC. So to delete a VPC, it's the same thing. You can just select it and delete VPC. So if you delete a VPC, it will show what are the other resources which are associated to it, which will get deleted. So in this case, one subnet and one security group will get deleted. So if I give delete and click on delete, so it will delete the VPC, the security group and the subnet associated to that particular VPC. So so it's that simple. So now let's start off with creating a VPC. Click on create VPC, provide a VPC name. So let's say VPC, and then you can provide a CIDR block. So I'm just going to provide a simple 10.0.0.0/16 so that it will allow lots of possibilities for me. So only these two would be closed, and then basically if I so I can change this as well if I want to. I can change this like this. Okay, so it doesn't matter. Okay, so we'll create another VPC with a different CIDR block. For now I'm using this, and I don't want any IPv6 CIDR block, and I'm going to keep the tenancy as default. So what tenancy means is if you use a dedicated one, it'll give you a dedicated VPC in one particular physical hardware. So you can run instances in your VPC on single tenant dedicated hardware. So that's the only difference. But if you choose dedicated, that will cost you even more than the default one. So the default one is basically common for everyone. Your VPC will be created in a hardware in which there are other people who also have created VPCs. Even though they are logically separated, even though they are logically isolated, even in that case, they are all in the same physical hardware, right? So that's the only difference, and also it will cost you more. Dedicated will cost you more. And then if you want, you can provide the tags. So I've already provided the name for it and it automatically took it as the tag. So I'm going to use that and I'm going to create the VPC. So that's it. A VPC has been created. Okay, so now let's just look into the configuration, which is here. So the CIDR block which we have provided, all right, and then DNS host names are disabled, DNS resolution is enabled. So a main network access control list is created, a main route table is created, DHCP option set is created, and yeah, so pretty much whatever we need is created. So let's look at the DHCP option set. Over here, as I told you, it will have all the information like the domain name servers and all that. So the EC2.internal domain name, Amazon provided DNS. This is the domain name servers. All right. Okay. So this is DHCP, and then also the main route table. So as I told you, a main route table will be created. Later, if you want, you can create another route table and associate it with the VPC. Again, I'll also show you that later in the demo. So now this is the main route table. Yes. You can see which VPC it is associated with, the scalar VPC which we just created. Okay, so we can see the routes, and there is only one route which is the local route. So we also looked into it. So the local route will allow communication between the VPC itself. And if you want to edit, you can just click on edit routes and you can add route. Yeah, so you can basically change it over here. So you can see instance, network interface, gateway, load balancer, endpoint, local. Yeah, so you can add a route and you get more options. So the thing is, you cannot remove the local target, you cannot remove the main route. The thing is, if you remove the main route, that will basically remove the communication between the VPC. So basically Amazon or AWS themselves do not allow that. So you can see the thing, right? There is no option to remove this particular route, remove this particular route. Okay, later if you want, you can add routes. If not, it's fine. Okay, so this is the main route. Okay, and then there is a main network ACL. So again, as I told you, this is more like a rule set. So there are inbound rules. So all traffic is allowed, and outbound rules, all traffic is allowed. So there are certain things which you'll have to know in a network access control lists. So the rule number will basically tell you what is the first rule which has to be executed. So if it's 100, then it will be executed first, then it's 50, it will be executed second, and if it's star, it will be executed at the last. So basically you'll have to know what is that hierarchy, or which has more power. So that will be provided in the AWS documentation itself. So we can just have a look at it. Network ACLs. So this is the documentation. And yeah, so optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of more or one subnets. Okay. Yeah, so here is the rule. So this is a default network ACL, and coming to the next part. So the network ACL has outbound rules 100 and 110 over here. HTTP and HTTPS are allowed out of the subnet. There's a corresponding inbound rule that enables responses to that outbound rule, inbound rule 140. So you can see, right? So according to the order you provided and according to the number you provided, that will basically determine the hierarchy, or it will basically determine when should what be executed. So for more info, again, you can check out the documentation. You can go through this entire thing. So you can see here, right? They've also provided comments. You can allow a certain port number from a certain IP address. You can deny a certain port number from a certain IP address. Yeah, so this is basically network ACL. Again, you can learn about the basics and all of it in the documentation itself. All right. Okay, so now going back. Okay guys, so we've created a VPC right now, but this particular VPC does not have any subnets. And let me just go to your VPCs, and now you can see, so we've created a VPC right over here. Yeah, so this is a VPC we've created. This is a VPC ID. The VPC is available, and over here CIDRs, we can see the associated CIDR is this. We do not have any IPv6 address, and yeah, so pretty much we've created it. Okay, so the next step is creating a subnet. So again, to start off with, you can also use the VPC wizard, where you can create a complete, like a private subnet with a public subnet with a NAT gateway automatically. But it would be better if you learn by doing it manually, so that if you understand and do it manually, and if you know the concept and how it works, then you can use the wizard and create it whenever you want. So there's no issues with that. Okay, so the next thing, we have to create a subnet. Let me click on subnets. Okay, so now you can see there are already around 6 subnets. So all of these subnets are default VPC subnets. So why are there 6 subnets? Because in North Virginia, in this particular region, there are 6 availability zones. So if I click on this subnet, you can see this is for 1F, right? This is for 1B, for 1D, for 1E, 1C, and 1A. So these are basically for the default subnet. And over here you can see the IPv4 CIDR is provided as 172.31.48.0/20. Okay, so this basically means there are 4091 IPv4 addresses available. So also it should be actually 4096 total addresses, but the thing is, for 5 IP addresses would be blocked by AWS themselves. So like the first 0.03, 0.2, 0.1, so few of the IP addresses will be blocked, and some of it will be already taken, so that will not be covered. So it would be -5, and yeah, so that's basically it. Okay, yeah, so this is a subnet. So now let's start creating a subnet. So there is no separate way of creating a public and a private subnet. The only difference is when you create a public subnet will have internet access. It will be connected to the internet gateway. There would be a route to the internet gateway. A private subnet would not have a route to the internet gateway. That's the only difference between a private and a public subnet. Okay, the resources in public subnet would have access to internet. Resources in private subnet would not have access to internet. Only if NAT gateway is connected, they will have access to internet. But again, internet, there won't be communication, or there won't be a two-way communication. There will be just one way. Okay, now let's create one. So the first step is to select the subnet, and I'm going to select the subnet we've created. All right, and I'm going to name it as scalar subnet 1. Availability zone, we can choose one if we want to. If not, we can just leave it. I'm going to choose US East 1A, and CIDR block I'm going to provide as 10.0. So let's say we can make it 1/20. So this is one subnet which I'm creating. So if, let's say, if this particular subnet's IP address overlaps or goes outside of the range of the CIDR block of the VPC, it will throw an error. For example, if I do this, yeah, so let us. So now you can see the CIDR address is not within the CIDR address of the VPC. Why? Because the CIDR address of the VPC is 10.0.0.0/16. That basically means the first 16 bits will remain unchanged for any IP address which is within the VPC. So in that case, we can only change the last 16 bits. So that's why if we do 1 over here, so this won't be any problem now. We can create a subnet. Okay, so but before that, I want to create another subnet because I want to have a public and a private subnet. Okay, so to create another subnet, you can just add a new subnet over here, and I'm going to name it scalar subnet, or let me do one thing. I'm going to name it public subnet 1, and I'm going to name this private subnet 1. And that was 1A. This is going to be 1B, and this is going to be 10.0.20 and 24. So I'm going to give a different CIDR block So you can see CIDR address overlaps with existing subnet CIDR. So basically, this particular CIDR block cannot overlap the subnet, cannot overlap the IP addresses of the other CIDR block. So for example, let's say if I make it 20, so again, it still overlaps. So we'll basically have to change a few things. So the problem here is the first, so if it's 20, right? So this basically means the first, how to say that? Yeah, so 20 bits. So in this 8 bits are there, right? So in the 8 bits, 4 bits remain unchanged and the other 4 bits can be changed. So now in this again, if I give 2, this basically means then the 4 bits will remain unchanged and 4 bits will change, but it will still overlap with the IP addresses in this. So what I'm going to do is I'm going to make it this 0. I'm going to make it 1. I'm going to make it 0. I'm going to make it 2. Let's make it 24. Yeah. So I'm going to make this also 1, 0. Yeah. So now basically this first 3 characters, that is the first 24 bits will remain unchanged. And over here again, the first 24 bits will remain unchanged. So that basically means they cannot practically overlap. The IP addresses will not overlap. So that was the only problem, and now it is resolved. So you'll basically have to select the CIDR blocks accordingly so that they do not overlap each other. Okay, so now I'm creating the subnet. Yeah, so done. So 2 subnets are created. Yeah, so you can see, right? The other subnets without the name are the default subnets one, and the other 2 are this. So I'm going to do one thing. I'm just gonna give the VPC ID and just gonna keep my subnets available to show them. Okay, it'll be much easier to navigate, right? All right. So public subnet, private subnet. We've created 2 subnets, guys. But the thing is, still it doesn't matter. Both are not. It's not a public subnet. It's not a private subnet yet. Because over here you can see, so if I go to root tables, again even here I'm going to do one thing. I'm going to select the VPC. I think this is the VPC, right? Okay, so this is the 017. So I'm going to just 085. So this is the VPC, yeah. Okay, so this is a route table. So if I go to routes, so only the local connection has been established. So in this case, you will have to establish a connection to the internet gateway, which will be attached to the public subnet, right? Okay. So now subnets are created, guys. So later we'll be making them public and private subnets. So to do that, first we would need an internet gateway. So let me create an internet gateway. Alright, so there is already internet gateway, but this is the internet gateway of the default VPC. So first we have to create an internet gateway. So to create an internet gateway, just click on that, and I'm going to just put scalar internet gateway, create internet gateway, and attach to a VPC. So internet gateway has been created. Now we'll have to attach it to our VPC. So I'm going to click on it. I'm going to select the VPC which we've created and attach internet gateway. So we've attached it to the VPC. Okay, done. Okay, so this is the internet gateway which we've created. It's been attached to the VPC of our choice. So now we'll have to go to the route tables, and in this case, scalar VPC. So this is a route table. We can go to routes. So subnet associations, again, we'll have to associate a subnet, right? So to make, so we've created the internet gateway. Now we are set to make the public subnet an actual public subnet, because the public subnet should have access to the internet, private subnet should not have. So to provide access to the internet, first thing we'll have to do is create a route which will allow all traffic via the internet gateway. So to do that, click on edit routes in the route table, in the main route table. I'm going to click on edit route, add route, and I'm going to make it all IP addresses. 0.0.0.0/0 means all IP addresses. Target would be an internet gateway, and it will basically search for the internet gateways available, and the only internet gateway which is attached to the VPC of this particular route table is scalar IGW, scalar internet gateway. So I'm just going to select it and save changes. That's it. So we've attached the internet gateway to the VPC. So now the VPC has internet access. Now how to make the subnet a public subnet? So to do that, we'll have to associate the subnet to this particular route table. So we should not, so for example, so yeah, so we can do this. Yeah, so public subnet should be the only subnet which should be associated with that route table. Private subnet should not be associated with it. If it is associated with it, then that would basically mean it will also have internet access. Okay, so now going to route table and selecting the route table, going to subnet associations and edit subnet associations. So explicit subnet associations, subnets without explicit associations. So these are the only subnets which do not have any associations. So I'm going to associate them. So edit subnet associations, select the subnet which you want to associate and save association. That's it. So now we've attached, we basically associated this particular subnet and to this particular route table which is connected to the internet gateway. Okay, so now what I'm going to do is let's create a EC2 instance inside the VPC we've created. Okay, so we have a public subnet. So one thing we'll have to change is go to the subnet. So one thing you will see is if I click on this, you would see auto assign public IPv4 addresses is disabled. So we'll have to basically edit this into allowing that, because when we create an EC2 instance within the subnet, it should basically create a public IP address for it. Okay, so to do that, we'll have to change it. We've selected the subnet. Let's see if there is an edit option here. View details, action, edit subnet settings, and we're going to enable auto assign public v4 public IPv4 addresses. So any instance which is launched within the subnet will automatically have a public IP address. Okay, done. Okay, so that is enabled. Now going back to the EC2 management console. So I'm going to launch an instance. So I'm pretty sure you guys know how to do this. If not, please check out the previous tutorial, because I'll be just rushing through this. Okay, so it's the same step. So I'm just gonna go ahead and create an instance. So the only step you'll have to know is this particular step, step 3. So in this case, you'll have to change the network. So network, first scale a VPC and the public subnet. Okay, and you can see there are 251 IP addresses available for the public subnet. Got it? Okay. And then so use subnet setting enabled. So in the subnet, the setting was enabled. So that's why it is using the subnet setting. That is, the public IP address is enabled. So when you create an instance, it will automatically create the public IP address for you. Okay, so these are the only things which we'll have to do. These are the only changes which we'll have to make in creating an EC2 instance to create an EC2 instance in your VPC, in your subnet which you've just created. Okay, so one more thing which you'll have to know is the network interface. So it will automatically create a network interface. You don't have to do anything. If you have a network interface already, you can create it. If not, you can leave it. It will automatically create one. And also you can associate a Elastic IP address to it. So I'm not going to do it right now. I'm just going to create an instance. Because I just wanted to show you guys, we've created a VPC, we've created a public subnet, we've created an internet gateway and provided the route. So now once we connect to it, it should let us download something from the internet. So basically the instance, right, which you are creating, the instance should be able to download from the internet. If it's not able to download from the internet, then we've not created a public subnet. It is not able to access the internet. Okay, so now next, add storage. I'm just going to leave everything in. So I just need SSH. I don't need HTTP or anything else. So I'm going to review and launch and launch. So I already have a key pair, which is it's tutorial key. Now acknowledge and launch instances. Yeah, so the instance is being launched, guys. So I'm just gonna so this is the IP address. So it will take some time to create it. So let it create, then we'll open the terminal and connect it and check if the internet is working or not. Okay, so now coming back, so we've created a VPC, we've created subnets, we've seen how to change routes in route table and how to associate a subnet to the route table. We've seen how to create an internet gateway. Okay, so now I'll also show you how to create an Elastic IP address and how to allocate the Elastic IP address once the instance is created. And so I'll also show you how to create a NAT gateway. So okay, so now let it create. it won't take much time. Yeah, so it is running right now. Let's first finish this part of this session and move on to the next part. Okay, so I'm going to click on connect. I'm going to click on SSH client. I'm going to copy this and I'm going to search for terminal. I'm increasing the size. All right, so now the file, the key pair file, is available in the downloads folder. So that's why I'm going to the downloads folder and then I'm hitting enter. So if it's successfully working, then it'll basically log into the instance which we've created within the VPC which we've created and within the subnet which we've created. So it's taking some time, so that I think it's still creating the instance. So it's still initializing. So maybe that's why it's delaying. So let's wait until it initializes, guys, so that we could just connect it instantly. Okay guys, so now you can see the status checks have been passed. So now we can start off with connecting the instance. So I'm just gonna click on this, click on connect, SSH client, copy the command and paste it over here. Let me just check. Oh, sorry, I'm not in the downloads folder, my mistake. Yeah, so what's the problem here? Yeah, so it's connected, guys. So it's successfully connected. I'm just going to clear the screen. Okay, so now we are in the instance. So now this instance should allow internet access, right? So that's what we've done. We've created an instance in the public subnet, and also internet gateway has been attached to the VPC, and we've also associated the subnet. So this particular subnet should allow internet access. So that's what we're going to figure out. So we'll see if it's able to update. So it's able to update, it's able to fetch data from the internet. So that basically means we've successfully created the VPC and a public subnet, and we've attached an internet gateway and provided internet access to the server. So we've successfully done that. Okay, so one part of the demo is done. So I'm just going to exit this instance. Okay, so let's just go back. Okay, so let this instance be, and let's go to the next part. So the next part would be basically NAT gateways, where we'll be creating a private subnet. So to create a private subnet, what are the things we need is we'll have to basically associate the NAT gateway to the public subnet, and the private subnet within the same VPC will access the NAT gateway in the public subnet, and that will do the network address translation of the private IP into the Elastic IP which is attached to the NAT gateway, and then it will allow us to connect to the internet. Okay, so that's what exactly will happen. So that's what we're going to do. Alright, so the first thing we'll have to do right now is create a NAT gateway, and let's do that. Move to NAT gateway, create a NAT gateway, scalar NAT gateway, selecting the subnet. So the subnet should be the private subnet. Okay, remember that you will have to select the private subnet. Selecting the private subnet, connectivity type, select the connectivity type for the NAT gateway. The NAT gateway should be public, but you're attaching it to the private subnet. Okay, and then Elastic IP allocation, you can associate an Elastic IP or allocate one, or yeah, so basically you will have to create one, right? So I don't have an Elastic IP, so that's why I was not able to select one. So for that, you'll just have to click on allocate Elastic IP. It will automatically create an Elastic IP and associate with the NAT gateway, because without the Elastic IP, it would not be able to network address translate the private IP addresses into the IP address which just has been allocated to it. Okay, so now create NAT gateway. So NAT gateway has been created, guys. It has been connected to the private subnet. Alright, so NAT gateway has been created. We've connected it to the private subnet, but there is one problem, because it's not associated directly with the VPC. So it's associated with the VPC, but it does not associate directly with the VPC. So that's what we'll have to do right now. Okay, so I just realized, so one small mistake we've committed is that we've associated the private subnet. So that's not the case. We'll have to associate the public subnet, because the NAT gateway should be created in the public subnet, right? So it's available right now. So I'm just gonna delete it. Delete. So we'll create another one in the public subnet. Okay, because it should be available in the public subnet. Then we'll have to create a route which will let the private resources to access the internet via the NAT gateway. So that's what we're going to do. So I'm just going to create the same name and change the name a little bit. Scalar NAT gateway 1, and select the subnet. Subnet will be public subnet. So we already have an IP address which already got allocated. So I'm just going to reuse it and create a NAT gateway. So again, first the NAT gateway would show status as pending. Alright, so then it will become available. Okay, so let it get created. So the next thing we'll have to do is we'll have to create a custom route table. So we cannot associate the private subnet to the main route table, because that will make the private subnet a public subnet, because the main route table has an internet gateway attached to it. So for that, we'll have to create a custom route table. So I'm going to route tables, create route table, scalar route 1 VPC, scalar VPC, and then create route table. So we've created a route table, guys. Okay. So next we'll have to do is we'll have to associate a subnet. So in this case, the only non-associated subnet is a private subnet. So I'm going to select that and associate with custom route table. So subnet association has been successfully done. Okay. So now I'm going back to routes. So if the NAT gateway is created, we can create a route. Let's see. So it's still in pending state. Let's go to route tables, and also so we've allocated Elastic IP address, right? So which got created, so that will be visible here. You can see that here. You can allocate IP address, you can release the Elastic IP address, you can associate the Elastic IP address to a certain instance. Right now, this particular Elastic IP address has been associated with the NAT gateway. So if you want to associate it with an instance, you can just click on associate. Once you've created the Elastic IP, then select the instance which you want to associate it to, and that's it. That particular instance will have the Elastic IP associated to it. So let's check if it's been created again. Yeah, so the NAT gateway is created, guys. So the next step is to go to the route table and create a route. And so one more thing I wanted to do is, so this one I just want to rename scalar main route. The main route. I'm just going to leave space. Okay, so this is scalar main route table. This is the custom route table. So now subnet has been associated. So the only thing we'll have to do is change the route in scalar route 1. So edit routes, add route, all IPs. We'll have to select the NAT gateway. So this is the NAT gateway. We deleted this, so I'm going to select this and save changes. So we've created a route for the private IP address. So now I'll do one thing. I'll just give this particular CIDR and NAT gateway. So anyway, we're going to allow only the IP addresses from the private subnet to access the NAT gateway, right? So I'm just providing the same CIDR block as the private subnet to avoid confusion. So that's provided, and save changes. Okay, so we've created the NAT gateway as well, and so it's successfully created, and you can see this association also has been made. Okay, so I think it's already was created. I'm just going to remove this then. Okay, so done. NAT gateway has been created. So now the only thing we'll have to do is we'll have to create a private instance and try to access the private instance from the public instance. And then once we do that, then the next step would be to try to access internet from the private instance. So now the private instance should not allow internet. Let's say basically it should not allow internet if there was no NAT gateway available. So if there is a NAT gateway available, it should allow. So what I'm going to do is, to show that, I'm just going to remove this. So first let's create a private instance and connect to it, and let's see if internet works in that or not. And then we'll associate a NAT gateway, and then we'll see whether the internet works or not. So that basically will prove, that will be more of a proof of concept, right? Okay. So now I'm going back to the management console. I'm going to create an instance, which would be again Ubuntu the free tier 1. Instance details, again scalar VPC, but in this case it would be the private subnet. Done. So in this case you can see it's in disabled state. Okay, next. Okay, I'm just going to leave it like this. Next, review and launch, existing key pair, tutorial key, and launch instances. Okay, so we've launched the instance. So this instance will not have a public IP address, it will only have the private IP address. Okay. So the first thing we'll have to do is we'll have to log in into our public instance. So only via the public instance we can connect to the private instance, because they are within the same VPC and they can communicate. So even though they are in different subnets, doesn't matter, they are within the same VPC, they can communicate without any issues. Because you don't need internet to connect these two instances, because they are within the same logical network. So in that case, they could communicate and they could these resources could connect with each other without internet access. So I'm just gonna connect to my instance again, and I'm gonna go back. So the thing is, it will take some time because it's a new VPC and a new subnet. So usually when it's a new subnet, then the status checks will take some time, because that is the first status check happening inside that VPC, inside that subnet. So that's why it takes a little bit time. Okay, so why is this not connecting now? So I think it's the terminal issue. I'm just going to open another. Yeah, so it connected. So it was the terminal issue. I think it got stagnant. Okay. And yeah, so we'll just click on this. So now if we click on connect, again, it does not have a public IP address, so we cannot connect to it. But we can connect to the instance via the private IP, but only we can connect to the instance via the private IP via a resource within the same VPC. So we've already logged in to a resource within the same VPC. So we can connect to the private instance only from the resources available within the VPC. So that we can do. I'm just going to paste this. Okay, so one small thing we'll have to do is that we'll have to upload the tutorial key to this. So I'm just gonna do one thing. So as I told you, the first thing we'll have to do is connect it to the private IP address. So connect it to the private instance. But the thing is, we do not have the PEM file. So the thing is, I copied the PEM file using a copy command and it has successfully worked. So I've already have the file. So the copy command would go like this. So I'll just show you guys. So it would be scp-i, and here you will have to put in your PEM file name of the public instance which you want to copy. Then here you will have to put in the file path. So this is the file path and the file name. It's actually tutorial key, right? Not tutorial, my tutorial. Yeah, so tutorial key. Okay, so then you will have to basically provide Ubuntu at the IP address 239.226.236. So what this basically does is it accesses the instance, and it does not log in into the instance, it just accesses the instance. So I'm just going to put a sudo also, so once it accesses the instance, it basically will copy the file into the default folder. So you can also mention the default folder, like for example, where do you want to copy, home and Ubuntu. So this is where I want to copy the file. Okay, so then I can just put this. This would be the command, guys, to copy the file. So you can just hit enter, and as I put sudo, it's asking for the password. I'm putting in the password. So so it's showing permission denied. So only thing you'll have to do is you'll have to change the directory and then copy it. That's it, it'll work. And this will be the command. So if this doesn't work for you guys, what you can do is you can basically I'll show you something. FileZilla. So in FileZilla, you can basically download the macOS client. So this is the macOS client. So you can download this and you can connect the thing via this. Okay, so you can basically just download this, install it, and yeah, you can connect the instance to this and just upload the file via FileZilla. So this is one option, but I'm not going to show FileZilla in this because that's again a bigger topic. Okay, all right. So we already have the tutorial key.pem file in our public instance. So the only thing we'll have to do is connect to our private instance. I'm going to copy this and paste it. So now we are in the private instance. You can see that, right? So now we are inside the private instance where we connected it from the public instance. We cannot directly connect to the private instance because it doesn't have a public IP address, but we can connect it via the resource which is already within the VPC. So that thing we've done. So now there is no NAT gateway attached. So let's do one thing. Let's try to do this. So you can see, right, it's at 0%. It's not able to connect to the internet. Okay, so I'm just gonna stop it. Okay, so let this just be here. Let's just go over here again and let this be. Now let's do one thing. Let's now create this route to the NAT gateway. So add route, NAT gateway, choose the right one, save changes. So the route has been added, guys. Okay, it has been added. So now let's try to run the same command. Could not get logged. Okay, so let's try again. Okay, let's do one thing. Let's just log out. Okay, so now we are in the public instance again. So let's try to so we are in the public instance again, guys. So now let's try to connect back to our private instance. Okay, so now the NAT gateway is attached. The route has been created to the VPC, to the private subnet. It is associated with the route table. So now we can basically try to, and now internet is working in the private subnet. So we can just try, we can install sudo apt-get install apache 2. It's downloading, guys. So basically now we've established internet connectivity in the private instance as well. So we've established internet connectivity in the private instance because you can see it's the private instance as IP address, right? So that's what we've done. We've successfully created an architecture. So what architecture we've created? This is the architecture we've created. Let me just open this. So this is the architecture which we've created manually. So there is a public subnet in which we have an instance. There is a private subnet in which we have an instance. In the public subnet, we have a NAT gateway which is associated with the private subnet via a route table. Public subnet is associated with the internet via the internet gateway, again via a route table. So this is the thing which we've created manually. So now if you select this, you can automatically create the entire architecture just using multiple steps. So you can basically provide the CIDR block over here. You can provide the VPC name, public subnet's name, private subnet's name. More than enough, it will automatically create everything for you. So but the thing is, if you don't do it by yourself, if you don't practice by yourself, you would not get the point. All right, so these things we've done, guys. I think you understood, right, how to do the public subnet, the private subnet, how to connect from one instance to the other instance, how to make sure if the internet is working or not. So everything we've done. So now what I'm going to do is I'm just going to terminate this because I don't need these anymore, and I'm going to close this. So the last part of this particular tutorial, the last demo, would be the VPC Peering Demo. So for that, we need to create a VPC. So let's just create a VPC using the VPC wizard. So I'm just going to select, let it be the same. I'm going to make this, and I'm going to make this, and I'm going to give preference as this, and that's it. So I'm going to create the VPC. So it created the VPC, it created the internet gateway, it created the public subnet, it created everything which we required for us. Okay, done. So now if I go to VPC, a VPC has been created. I'm going to name it as scalar VPC 2. So why did I create this? I just created this so that I can show you the peering demo. So going to peering connections. So we're going to create a peering connection between this scalar VPC and this scalar VPC 2. We're going to create a peering connection between these two VPCs. I'm going to go back to peering connection, create peering connection, and so name we can provide as peering practice. So the local VPC to peer with would be scalar VPC. So it's my account, another account. As I told you, you can also associate or connect to VPCs in another account, in another AWS account, but this is going to be my account. It's in the same region. You can also connect to a VPC in another region altogether, but it's in the same region. The acceptor would be scalar VPC 2. Okay, and then create peering connection. That's it. So this is more than enough to create, and then what you have to do is you'll have to accept the request. Done. So to send and receive traffic across this VPC peering connection, you must add a route to the peered VPC in one or more of your route tables. Okay, so let's modify the route table. This is the main route table. You'll have to go to routes, edit route, add route, same thing. So here it would be peering connection, peering practice, save changes. So this could be basically the IP address of that particular peering connection as well. I'm just gonna go back. And I'm gonna copy this and go back to route tables, scalar main route table, routes, edit routes, add route, add the IP, select peering connection, select the peering name and save changes. That's it. So now one more thing you'll have to do is, so this established one-way connectivity. Now one more thing you'll have to do is we'll have to basically do the connection for the other VPC. So this is what? Scalar VPC 2. So this is the, let me just check. Scalar VPC 2 route. No, so this is the main route table of the scalar VPC 2. I'm going to name it scalar VPC 2 main route. Done. So in this again, I'm going to make a rule change. Edit routes. Peering connection, peering practice, save changes. So done guys, so that's it. So now if there are any resources in either of the VPC, so let's say there is an instance in this VPC and there is a database server in this VPC. So this instance could access the database server, and if there is an instance in this VPC and there is also another instance in this VPC, they can also connect. So basically like how we connected to one private instance from the public instance, same way we can connect to the instance inside VPC2 from VPC, or we can connect to the instance in VPC from VPC2. So vice versa, we can do anything we want. So these are the things guys. So we've learned about VPCs, we've learned about subnets, we've learned about route tables, we've learned about internet gateways, we learned about Elastic IP addresses, we learned about NAT gateways, peering connections, and security groups we've already learned in the EC2 tutorial. And one more thing, what was the one more thing? Yeah, so the network interfaces. So we've learned a lot of things. I hope you guys understood what exactly was going on over here. So now what you can do is, so let's say I can just delete this, but it has a peering connection. So the first thing you'll have to do is delete the peering connection. So if I delete the peering connection, I think it'll ask me to remove the routes. Delete related route table entries. Yes. So now we are deleting the peering connection and also deleting the routes. So it has been deleted successfully. So now let's try to delete it. Yeah, so now we can delete it, and it will basically delete all the resources associated with it, so you don't have to worry about it. Done. It's all deleted. Okay, so now scalar VPC is there. Again, we can also delete this as well. I'm just going to click on it and delete it. So again, there is one issue because there is an Elastic IP address attached to it. There is a NAT gateway attached to it. So the first thing we'll have to do is go to Elastic IPs, and so yeah, it's attached to the NAT gateway, right? So first we'll have to delete the NAT gateway. Delete, and then go back to Elastic IPs, refresh this. So it's allocated. I don't think we'll be able to dissociate it right now, so it has to be completely deleted. Only then we can disassociate. This is a network address card. It's connected to this NAT gateway. So is it deleted? So NAT gateway is deleted. Okay, so it takes some time, so let it be. So now let's just go to VPCs and try to delete it. Yeah, so it's still saying there is a network interface. So as there is a network interface, it's not letting us to delete it. So I'm just going to open this and let's delete the network interface. Okay, so again, the network interface is attached to the EC2 instance. So in that case, we can delete the EC2 instance altogether. So done. We have terminated the EC2 instances. Okay, so now going to network interfaces. So I'm just showing you how to clean up. So the network interface has been deleted. So why it was not allowing us to delete the VPC is because there is a resource within the VPC. So if we delete the VPC, that basically means we'll not be able to use the resource. So it cannot be done. So once you don't have any resources within the VPC, only then you can delete it. Now let's try it again. Delete VPC. So it still thinks it's in use. That's the problem. Yeah, so now we can delete it, guys. And so it will delete the public subnet, the security groups, private subnet, the internet gateway, and the route table. Delete and done. Okay, so we've created VPC subnets and we've also deleted them. An Elastic IP, as I told you, if you create an Elastic IP and do not associate it with anything, then it will charge you. So now the NAT gateway ID has been removed from here. That basically means it's ready to be deleted or released. So I'm just going to click on release. Done. So basically we've created everything and also cleaned up everything. So this is one of the important steps when you're practicing, because as I told you, if you just leave it like that, you might get billed. So to avoid getting billed, to just practice in the free tier limit, always clean up the resources once you have done with it. So guys, that's it for today. I hope it was helpful and informative. So if you have any queries, please leave a comment down below and we would love to help you out. And also if you like the video, please subscribe and share. Thank you.